Next topic, diffusion. So next topic is diffusion. Now tell me, what is diffusion? Anybody? Wait. Okay, listen. If I put a color molecule, color particle in water, the color particle concentration is higher at this side, slowly it will diffuse. Okay, this is called diffusion. Higher concentration to lower concentration, we call diffusion. Case 2, I kept semi-permeable membrane, I kept solute here. Semi-permeable membrane, solute here. Now what this movement is called? Higher concentration to lower concentration via semi-permeable membrane is called what? Wrong. What is osmosis? When you are saying, she is saying movement of water molecules. I am talking about solute molecules. Diffusion. In both the case, it is diffusion. Okay. Case 1 also diffusion. Case 2 also diffusion. కావాలా వద్దా ఆడబెట్టి ఫ్రెండ్లో దాగ్దండి ఆడబెట్టయిరా వాళ్ళకి ఇవ్వు సరే కింద పెట్టు నైస్ ఓకే ఎక్కడ ఉండింది అది నేను చూస్తే లేదే ఓకే ఓకే లేదండి సో మూమెంట్ ఆఫ్ సొల్యూట్ మాలిక్యూల్స్ ఓకే ఫ్రమ్ ఏ రీజియన్ ఆఫ్ its higher concentration to lower concentration with or without membrane is called diffusion. Remember, diffusion means solute is moving. When solvent is moving, we call it as osmosis. What solvent will do in osmosis? Because you kept solution here, this membrane is not permeable to these particles, hence water from its higher concentration will move to its own lower concentration, to a part of lower concentration. From its higher concentration to lower concentration, this is going to move. That we call it as osmosis. That is called as your osmosis. Okay. So this is the basics. Let's clear the basics. Diffusion means movement of solute molecules from their region of higher concentration to region of lower concentration. Osmosis, that this is with or without membrane. Osmosis, in presence of membrane, water molecules will move from their region of higher concentration to lower concentration. Has the only difference in defining the diffusion and osmosis is the word which you are mentioning. If you are using the word solute, then it is diffusion. If you are using the word solvent, then it is osmosis. Remember, only the word is different here. Now, we need to study diffusion. There are some principles. Okay, why we are studying this in pharmacy? Why? Reason, whatever drugs you take, drugs or nutrients, anything you eat, it has to first dissolve, converted into molecules, then this molecule will diffuse from your stomach to blood. Okay, stomach to blood via membrane, that is your intestine or stomach lining, they will pass through. So this has to be defined and it has to be scientifically expressed. For that, one scientist, Fick, okay, we call them as Fick's law. Instead of directly saying, listen to this, okay, instead of directly saying what is law, I can say this is the law, this is how it came, these are the units. What we will do is, we will create the equation. I will make you people to get Fick's name beside your name. For example, what is your name? Ismail. Ismail Fix. Why I am naming that? Because he is going to create the equation. I will make it to become that Fix. We will see that. We are going to create that equation. Okay, we want to create this Fix equation. We will try to see. For that, come. I want molecules, not molecule, molecules. I want membrane. Come. This person. Hey, Nuvera. Come. Hey, come. Get that book. I want one more person here. Please, come. You are getting chance to be YouTube. Get PhD in YouTube. Babu, see, you need to leave this event. Okay? So, behave yourself as a molecule. What molecule will do? There will be random motion. Do it random motion. Keep on moving. That was random motion. Move. Don't. Random. We should not predict where you are going. Good. Hold this. You go that side.
Like this?
Yeah. You hold like this. Okay. Listen. This what happens when concentration is more. This we call it as Brownian motion. Brownian motion is reason behind diffusion. For the molecules to diffuse, you required Brownian motion. This is called Brownian motion. Now, when we start diffusion, what happens? Because they are moving here and there, they are getting crash with each other. This molecule one by one slowly moves through semi-permeable membrane. It will move from this side to that side until there is equal molecule distribution. I am not showing equal molecule here, but assume that there is equal molecule distribution is there. Until then the particles will move. Now I want to write this event in equation. I want to write this event in equation. Once again I will create. You tell me what are the points to be noted here. Come. Don't roam, just stand there. Okay. Yeah. What is happening? Molecules are moving from here to there. Molecules are moving from here to there. I want to know how many molecules are moving at a given time. What we call that process as? How many molecules are moving through semi-permeable membrane at a given time? What we call that process as? Anything divided by time. What we call that? Rate. Okay. I want to express rate. So I want something divided by time. What should I keep here? So what to keep there? Now each molecules have their own mass. They have their own mass. So I want to represent how many molecules are, how much mass is shifting from here to there. So how to represent change of mass here? What is the equation for change of mass? D M2 minus M1 is called dm. I will write dm. So what is dm by dt is rate of change of mass. How much mass is here this side? When the process is started, what is the mass this side? Rate of change of mass. Okay. What is the mass this side and what is the mass this side? Rate of change of mass. And this mass is passing through a semi-permeable membrane, and this membrane has some area. To represent area here, what should I write? Directly write S here or 1 by S?
1 by S.
Why 1 by S? My question is, I want to represent area here. Whether I have to multiply or I have to divide, which is correct for this situation?
Time square. The time square.
Concentrate upon area. Okay. Assume that, okay, you can go. Thank you. Okay. Assume that door has a semi-permeable membrane. Assume yourself as a molecules. So molecules are moving from here to there. I am noting down some mass is going from here to there per given time. Have written rate of change of mass. Okay. Through the surface area of the door, semi-permeable membrane, you people are going out. How to represent that in equation? Molecules are passing through a semi-permeable membrane which has some surface area. How we say? Movement of molecules per area or movement of molecules through area? Per, you need to say per. Per given area, what is the rate of change of mass? So I need to keep 1 by S. This is called J, which is known as flux. Okay. So rate of movement, no need to by heart. Remember, if you listen to this carefully, you will remember it. No need to by heart. Rate of movement, rate of change of mass per unit surface area is called flux. Now, why the molecules are moving? I just said. What is the reason behind their movement? Brownian motion. Okay. Why the Brownian motion kicks here? Why they are in Brownian motion? Because their concentration is high here, they are low. So what we call this? Concentration high this side, low this side, divided by what is the length. If I increase the distance, the concentration effect will decrease. If I decrease the distance, the concentration effect will increase. So what we call that? Change in concentration per distance is called what? dC by dx is called what? Gradient. We call it as a concentration gradient. If students are more here, students are less there, I say student gradient. Like that, concentration is more this side, concentration is less this side. Okay. This side we have more concentration, more molecule, this side we have less molecule. Hence they are moving. Once the concentration becomes equal, there will be no movement, there will be no further movement. So rate, why flux is kicking in? Reason flux is kicking in because there is concentration gradient. Flux is directly proportional to concentration, we call it as concentration gradient. Flux is directly proportional to concentration gradient. Now you can use his name beside your name. You just created a equation. This is called Fick's first law. What is Fick's first law? Define. That's all. It is defined as flux is directly proportional to concentration gradient. That's all. That what is Fick's first law. Fick's second law is there. Flux is directly proportional to concentration gradient in 3 axes: x axis, y axis, z axis. That's all. This is single axis. If you take this into 3 dimensions, then it will become second law. Second law we are not using that much, but for time being remember Fick's first law. This is first law. Fick's first law. So what we just did, we have a mass of molecules moving here to there via semi-permeable membrane. To quantify this, to represent this in the form of equation, we use a term called rate of change. Rate of change. For given time, how much rate is changing, how much molecules are changing. Because molecules have their own mass, hence we are changing rate of change of mass. This rate of change of mass is occurring via semi-permeable membrane, and the semi-permeable membrane has some area. So rate of change of mass per unit area is direct. Why this is rate of change of mass is occurring? Because there is concentration gradient, because there is difference in concentration, hence we call it as rate of change of unit mass. Okay. Concentration gradient. Remove the proportionality constant now. I don't want proportionality constant, I want an equation. So to remove the proportionality constant, we are keeping a constant called d, and we are mentioning negative sign here. I will tell you why that. dC by dx. This is the equation for Fick's first law, which is defining your diffusion. Now remember, d means diffusion. I am telling it as a I just said remove the proportionality constant and keep constant, but we are not saying it as a constant. We should say what is this? Diffusion constant. No, the name given is diffusion coefficient, not constant. Now tell me, how will you decide when the constant is behaving as coefficient and constant? In what case? I think I already told you. In what case, if I write A is directly proportional to B, remove the proportionality constant, will keep some constant. This is named as coefficient and constant depending on particular state. What is that? When we call constant as coefficient and constant. For that you should know what do you mean by constant? It is not changing. That is called constant. What do you mean by coefficient? Why I should call coefficient? I can say it as a change efficient. Why I am saying coefficient? Why I am using the word co? It is constantly changing with some other change. I will say colleague who is working with me, like that co-worker who is working with me. This diffusion coefficient will change if you change concentration. Diffusion coefficient will change if you change temperature. Diffusion coefficient will change if you change pressure. You do whatever, it will change. It is not constant. In that case only constant is named as coefficient. We name constant or coefficient when it is coefficient with other things. Hence I am making as a diffusion coefficient. Sir, why negative sign? Can you tell why negative sign? As time progress, the flux will decrease. As the time progress, let us say 100 people are there. Slowly, initially they will move fast. When they are about to reach 50 here and 50 here, what happens? Nobody is moving. To represent this, as you go forward, there will be decrease in this process. For that, I am using negative sign in the equation. If I keep positive sign, it means it is continuously going from here to there. I am using negative sign, it indicates this process is decreasing. So we will see individual. What is dm? Change in mass. What is dt? Change in time. What is S? Surface area of membrane. dc? Change in concentration. dx? Distance. What is the distance? I will tell you. m2 minus m1, t2 minus t1, c2 minus c1, x2 minus x1. That I am writing as d there. Okay. Change in distance. Now we need to map the units for this. Remember, units also I don't know how they taught you in +2. I don't know that one, but learn this process. First we will create unit for flux. Okay, what is flux? Mass by time. What is change in mass is called as, what is the units for mass? CGS system. What is the units for mass? What is the unit for mass in CGS? We are saying na G. Okay. So dm means, you only tell what I have to give. Gram. What is dt? Second. What is remaining? 1 by good. Centimeter. See, I use all three. In CGS, I use all three. Centimeter, gram and second. Okay. You got how I am keeping? So what is the units of flux now? Gram per second per centimeter square. That's all. So no need of behatting the units. You can create the units. You should know only the basic. If you know that basics, from that basics you can create the equation. From that equation you can create the units. No need to behat. Okay, these are the units for flux. Next, what is the units for concentration gradient? Okay, express concentration in CGS system. See, you can't express concentration in centimeter, you can't express concentration in seconds. The only option for you is gram. How will we express gram in CGS system? Sorry, concentration in CGS system. How to express concentration? Molarity, molality are not that system. I am telling you CGS. You need to use only gram to express concentration. For that, concentration is how much amount of solute is present per given solvent. This is also one expression for concentration. We have normality, molarity, etc., etc. Along with that, another expression is how much salt I am adding in given water. That is also expression for concentration. So gram per ml. So I will write here concentration means gram per ml. What is dx? Centimeter. So we can write that gram per ml into centimeter. Convert this ml in CGS system. See, this is the basics. You don't know the basics. Please learn it. Convert ml in CGS system. Use in system. What is this? C. Express centimeter in ml. Centimeter in ml. Express. Hey, listen. If I want to measure the volume of this room, what I will do? I will measure what is the distance here, what is the distance there, and what is the distance there. Distance into distance into distance. What is that? Cube. So I need to write, instead of ml, I can write G by centimeter cube into centimeter. Basics, please learn. ml means centimeter multiplied by centimeter multiplied by centimeter. Area 2 centimeters. Volume you need to multiply 3 centimeters. Basic. Okay, 3 centimeters. So what we got now? Gram per centimeter. No. Multiply this 2. Centimeter power of 4. Yeah, come here. So this flux is what? Gram per second per centimeter is equal to minus D. What is the units for this? Gram per centimeter. Okay, sorry, my mistake. So centimeter square, and we have centimeter to the power of 4. Now we are creating the units for, we created the units for flux, we created the units for gradient. Now we are creating the units for diffusion coefficient. No need of by adding. Create the units for diffusion coefficient. How I have to do? I have 4 here, 2 here. Cancel this. What is remaining? Gram will also cancel. Tell me the remaining. I want D to be expressed. Send this side and tell me what is the equation. Centimeter square by. Very good. That's all. You can represent minus here. Don't send minus that side. Okay. Or because we are expressing unit, no need of mentioning your negative sign. We express negative sign when we are representing in the form of equation. Units, no need of representing the negative sign. So the units for diffusion coefficient is centimeter square by second. Never by hat. Till now I didn't by hat. I don't know units. What I will do it in my mind, I do all these calculations. You need to train like this. Within a fraction of a second, then only you can crack your GPAT. You should do everything in your mind in a fraction of seconds. Okay, try to adapt to this one. Okay, see what we just did. We studied some basics. The basic what for creation of units, what I did, I took one basics, that is CGS. Basics is CGS system, any one system. So all the whatever the variables we have, we convert that into CGS system. Okay. For that you should know, basics should be known. Basic, first basic here is the mass in CGS system is gram, time is second, and distance is centimeter. Problem came this side. You don't know how to express concentration in CGS system. You don't know that. How to express concentration in CGS system. Okay. You don't know that. For that, one of the concentration expression is how much of solute is present in given solvent. So I have written this gram per ml. divided by, what is the thing, x is centimeter, distance is centimeter. Now ml is different term, it is not falling under CGS. I want to convert ml in CGS system. For that you should know, if you multiply the length by 3 times, you will get the volume. So centimeter, centimeter into centimeter. So centimeter cube. Another centimeter is there here. So that will also add up, it will come to the power of 4. See here ml is up, centimeter is down. Here I am writing side by side. If you don't know this, go and ask your maths teacher. You know what is that? A by B by C, you need to take divided by 1. If you send, it will become 1 by C. So both are multiplied, see. So I am multiplying it. And you are getting this one. Now finally what you have done, you are equal, as per the equation you are writing your units, individual units, and strike out what are the common terms are there. Once you strike out what are the common terms are there, you will be left with the equation and rearrange the equation. You just created an equation and also you have created its units. This is called your Fick's first law. To summarize in a short, Fick's law says that, see, many teachers what they will do, they will directly say, okay, Fick's law is defined as flux is directly proportional to concentration gradient. This is called flux, this is gradient. Write down, over. If you do like this, you won't learn anything. We created it. We learn what is the process. Why those molecules are moving? Because concentration is more. When concentration is more, molecules will collide with each other. They want to move. So what is the energy behind the diffusion? That is your Brownian motion. Actually, concentration gradient is the energy behind the diffusion. But why molecules are moving? Because due to Brownian motion. So molecules moved from here to there. So we quantified it as a change of mass, rate of change of mass. From which they are moving? From a semi-permeable membrane they are moving. They are moving through a semi-permeable membrane, and that membrane has some area. So rate of change of mass per unit area is called flux. Why that flux is happening? Because there is concentration difference. So that we represented as concentration gradient. We represent that as concentration gradient. Next we equated it. That what is Fick's law. Flux is directly proportional to concentration gradient. Then we are going to diffusion. We are removing the proportionality constant. We are keeping some constant called diffusion, but we are not naming it as a diffusion because this constant is changing for everything. Change temperature, it will change. Change concentration, it will change. Change pressure, it will change. So instead of naming it as a concentration constant, we named it as coefficient. We call it as diffusion coefficient. We created individual units, then we combined them and created the unit for diffusion coefficient. So what is the definition given in textbook for Fick's first law?
In diffusion, molecules get transported from one compartment to another over a period.
Don't read that definition. Fick's law.
Is equals to 1 by S into dm by dt.
Written format.
Fick's first law states that the flux is directly proportional to concentration
Gradient. See, as per textbook, you just created it. This how you need to learn. If you mug up or bad, gone. Okay. Please learn concepts. So what we did, because I know all the things in the concept, I know full concept because I am teaching from so many years, I know that. So I created this. Now what you have to do is learn that conceptually. Learn it conceptually, you will never forget. Okay. You will never forget, learn it conceptually. Any doubts in this? Write down quick. Cut chera. నీకే చెప్తున్నా కట్ చేయి నేనైతే ఇలానే ఉండి ఓకే దిస్ వాట్ ఈస్ Fick's సెకండ్ లా dc by dx in x axis, y axis and z axis. Fick's second law is diffusion in 3 direction. First law is 1 direction. If it is 3 direction, we say diffusion in 3 direction. See, this happens 3 directional diffusion. Where it happens? If you are not using, see, if I am using semi permeable membrane, the direction of diffusion is 1. Tell me when the diffusion is 3 dimensional. if I use one door, you have to go through that door, so one direction exit. If everything is open, you can go from anywhere. Means what? If I add a solute directly into solvent, let's say color solution, if I add color solution in solvent, obviously this color will go in all directions. In this case we will apply this one. Once you keep your semi permeable membrane, once you keep your semi permeable membrane, then the direction is unidirectional. There we use fixed first law. This is your fixed second law. What textbook is saying about second law?
Fixed second law states that the change in concentration with time in a particular region is proportional to the change in concentration gradient at that time of point.
What do you mean by that? See, something different it is. What he is saying is, listen, we have solute. X-axis, Y-axis, Z-axis. Listen, fixed second law is saying that your flux will go in a direction where there is more change in the concentration gradient. That's all. That what is the explanation. Listen to her, what is it? What I said, simplified version of fixed second law. Flux will go in a direction where there is more change in concentration gradient at any given point. It may be x-axis, it may be y-axis or z-axis. For the flux to go in y-axis, the concentration gradient should be more in y-axis. Then it will go this side. If the concentration gradient is more on x-axis, it will go that side. Flux will go that side. So repeat that statement. Second law
States that the change in concentration with time in a particular region
change in concentration with time in a particular region is proportional to change in concentration at that point. At that point, what is the change in concentration? That what we are going to check there. At that particular point, what is the change in concentration? That how you define. Remember how to remember the definitions. Definitions can be created, I said. Okay. If you ask me to define this one, how I will define is, the flux will move in a direction where there is more concentration gradient. Or simple definition. Textbook is defining like this. I am defining like this. Simple. Flux will go in a direction where there is more change in concentration gradient. That's all. Okay. Stop it.